everyone, good morning. My name is Rishikeshan, son of Tanabalan. My matrix number is 16 DKM 19F1090. I am from Polytechnic Tuanku Sultan Bahia. Today I am going to do a lab experiment on beam apparatus. So let me explain you what is beam apparatus. Beam apparatus allows an extensive range of experiments to cover virtually all course requirement relating to bending of beams. So in this experiment we use three types of beams: cantilever beams, overhanging beams and simply supported beams. And we use three types of loads, which is point load, ununiformly distributed load and coupling load. So what are the objectives of our experiment today? To determine the value of supporting force. Next is understand the term equilibrium. The third one is understand the concept of beam apparatus, and the last one is to memorize the formula given. So today I'm going to conduct an experiment from home about beam apparatus. So the apparatus I'm going to use today is everything from my home. So this is 30 cm steel ruler which can easily bend. So this will act as beam in our experiment today. Next is the load, which is a container filled with stones, and then we will use rubber band. This rubber band will be used to connect the load to the steel ruler, and the most important one is these weighing scales dynamometer, which we will use to measure our weight for the experiment. So guys, this is the setup for the lab experiment. As we can see, that is load, that is our steel bar which acts as a beam, and this is the weighing scale, also known as dynamometer, and we used to tie all these using these rubber bands, the joints. So now let's we take the record. So as now you can see, the load is at the center of the beam, and now we will check the weight of it. So now the scale is in kg, so we will change it to Newton later. So next we will move to the second situation given. So we go to the 28 cm. So this length is 30 cm, the total beam length. Now we move it 28 cm to the right side. We have 2 cm gap over here. Now we move to the third situation. In third situation, we move to the right side of the beam, just 1 centimeter away from the right side. Okay, now we'll take the recording for the first lab, the third situation I mean. Alright, so that's all for this lab section. Now let's we move to the result and data. So next we will look at the readings that we obtained from the weighing scales dynamometer. So our force, which means our load, is 2 kilogram, which then I convert to Newton is 19.62 Newton. So we have three situations here. The first situation is where the force applied is in the middle of the beam. The total length of the beam is 30 centimeters and the force applied is 15 centimeters in the middle. So this is FA, this is FB, this is FC. When the force applied, we get FA 10.79 Newton, which is same with the FC 10.79 Newton. In the second situation here, we can see that the load applied is at the end of the beam. So it is 2 cm away from FC, the applied load, then the FA is like 28 cm before the applied load, and the result we obtain is Fa 9810 Newton and Fc is 11.77 Newton. Next, the third situation we see the applied load or applied force is just 1 centimeter away from the beginning point, which is Fa. So the rest is 29 centimeters to Fc. So the first Fa is 12.75 Newton and Fc is 9810 Newton. Alright, next we will look at the theoretical calculation. So this is our beam. The force is applied on the center of the beam. It is 30 cm. This is Fa and this is Fc. The load applied is 19.62 Newton. So we will do the calculation using the formula in the x-axis. Fa plus 19.62 plus Fc equals 0. So we get Fa plus Fc equals 19.62. Then we will do the moment clockwise positive. Then we will do the moment. We apply the formula and we find the Fc we will get 9.81 Newton. Then we will substitute first equation into the second equation. So we get Fa equals 19.62 minus Fc. After solving this, we get Fa equals 9.81. So from this we can conclude that Fa and Fc has the same value. This is because the force is applied at the center of the beam. So this force is distributed uniformly. Next we look at the shear stress and the bending moment. After apply formula, we will get the maximum bending moment equals 147.15 kilonewton meter. Next we look at the second situation of the beam, which is Fa Fc 30 cm length, but the force applied is 1 centimeter away from the beginning of the beam. So the force applied is 19.62 Newton. As usual, we apply the formula upwards x-axis. Fa minus 19.62, which is load, plus Fc equals 0. Fa plus Fc equals 19.62. Then we will find our moment. As usual, we apply the formula and we get Fc equals 18.97 Newton. Then we will substitute the Fc into the first equation. So we get Fa equals 19.62 minus Fc. So Fa we will get 0.65 Newton. So from this we can see Fa is lesser than Fc. Now let's go to the third situation, where the force applied is 2 cm away from the end of the beam. So the total length is 30 cm, the beam length, and the force applied is 2 cm away, which is 28 cm from the beginning to the force applied. So Fa plus Fc equals 19.62. As usual, we will find the moment. We get the Fc equals 18.31. Then lastly we will do Fa equals 19.62 minus 18.31, which we can see we can get 1.31 Newton. So from the calculation we made, we can see we get all the supporting forces. So this is measurement calculation. Supporting force of load at 19.62 Newton. First we will look for the load which is applied at 15 centimeter of the beam. So supporting force A in Newton is 10.79 Newton. Then in B is 10.79 Newton. This came through from the experimental way. Next we can see supporting force A is in B is in Newton is 9.81 Newton, and same goes to in B. So here we can see we get from theoretical formula. Same goes for the 28 cm spot where the load is applied. For the second situation, we get 9810 Newton for the A supporting force and 11.77 for the B. In theoretical, we get 1.308 for the A and 18.31 for the supporting force for B. Last, the third situation, we applied load at 29 centimeters at the beginning of the beam. So we can see we get supporting force A 12.75 Newton and B is 9810 Newton. From theoretical, we can see we get 0.654 for A and 18.97 for B. So this is the formula we use. Supporting force A equals F in bracket 1 minus XOL. For supporting force B, B equals F X over L. So from the result we obtain, we can say that there is difference in the values that we obtain from experimental ways and also calculation ways. This happens because the formula given always ignores the life factors. So apart from that, this also happens because due to human error, which is the person who is running the experiments is reading the is looking at the readings from the wrong position or ignores life factors. Apart from that, not only humans, machine can make errors too, and it can be a machine limitations. Errors often happens in machine is the zero pointer is not pointing right at zero, and device needs calibration. And you will always must remember, any device that is used to measure precision like length or dimensions, it has to be calibrated by time to time. Apart from that, the second question that we get is, can a metal replace with the steel bar as a beam? Yes, you can replace, but the supporting force will be different. They will be different because due to the metal, the beam material we change, because every material has different mechanical properties. So what we know from the result, what will happen to the result is it is depends on the material chosen. So it depends on the chosen materials mechanical properties such as tensile, strength of materials, Young modulus elasticity, and many more. So it solely depends on the characteristics of the or mechanical properties of the material. So that's all from me today. Thank you.